Well, hello there again, everyone. It's Chuck back with part 3 of making a refrigerant, a behind-the-scenes look. If you haven't caught parts 1 and 2, you might want to hit pause, jump out, view those, and then come back here and view part 3. But in part 3, we talked to some of our engineers around our applications testing, when we put things in calorimeters or actually do it in actual systems here in our laboratories. And then we'll talk to a couple of our field engineers, David and Andrew, who support our customers and OEMs when they start developing products or start using the refrigerants out in the field. And finally, we'll visit briefly with Jamey Hale, who has about 40 years in the industry, does a lot of training with contractors and AC technicians, and just show you the support that you can get from the Chemours team when it comes to using our Opteon or Freon brand products. Again, this series was meant to show you what's in the jug besides just a refrigerant gas, besides just the molecules, all that science, technology, know-how, understanding that we've developed in nearly 100 years being in the air conditioning refrigeration world. So I hope this was useful. Again, if there's any subjects or topics you'd like me to cover in future episodes of Refrigerant Checkup, please let me know. We'll put the contact information down at the bottom. But always appreciate your support and your comments. Please keep the feedback coming. And be sure to hit subscribe so you don't miss any of our future episodes. So I'm here with one of our Chemours engineers who works at the Discovery Hub, Jethro, and he's going to take us through some of the refrigeration testing that goes into developing a refrigerant, notably the compressor calorimeter and our systems lab. So welcome, Jethro. How about you introduce yourself and tell us a little bit what goes on in the lab, and then we'll take a walk inside.
All right, my name is Jethro Medina. I've been with Chemours now for about 4 years, working in the Refrigerants Testing Center. I have a background in chemical engineering, and I kind of oversee the day-to-day activities in the refrigerants testing labs. And what we will be seeing today are 2 pieces of equipment that are critical for product development for refrigerants. One is the compressor calorimeter, and the second is a set of environmental testing chambers. So what we have here is a compressor calorimeter, and it is used for the compressor evaluation of a variety of different applications in the HVAC industry. And it allows for a quick screening of multiple refrigerants for these different types of applications. And how it fits into the developmental process of refrigerants is that the compressor takes up a lot of the energy consumption of a refrigeration system. And being able to optimize or minimize the energy consumption of the compressor when developing a new fluid is very important for manufacturers of the fluids as well as the compressors. The compressor calorimeter consists of the compressor chamber over here, and this allows us to interchange the compressor depending on what application we're aiming to test for. In addition to the compressor, we have a variety of temperature sensors, the power meter consumption for the compressor itself, as well as discharge and suction pressure control. And how a typical test works is we decide on a condition. So suppose we're testing air conditioning. We'll take a standard that will provide us an evaporator and a condenser temperature to aim for an air conditioning application. We could then adjust the suction and discharge pressure to adjust for the temperatures that we're aiming for, and then allow the calorimeter to sit steady for about an hour to ensure that the controls are working properly and we're maintaining those conditions that we're aiming for. After the hour has passed, we will then take a 5-minute snapshot of all the temperatures, and particularly the energy consumption of the compressor as well as the cooling capacity of the fluid. And we could take those 2 values, the cooling capacity and the compressor power consumption, and evaluate that at different refrigerants as well as different compressors. So that's the compressor calorimeter and how it fits into the development of refrigerants. And now we are inside the environmental chambers. We just saw a shot of the indoor chamber. We are in what is typically considered the outdoor chamber. And the types of equipment we test in here consist of residential and commercial air conditioners and heat pumps. Any equipment that will require the use of an outdoor and an indoor condition is what we've been testing thus far. So the chambers themselves They provide very accurate temperature and humidity control, which is very important for modeling or for setting up the conditions you would typically see for different climate conditions depending on where you are in the world. So right now we actually have a residential air conditioner in the system. And the way this would work is we would set this chamber to an outdoor condition of sometime in the summer, let's say 95 degrees or so. Then the indoor chamber will be set to your typical in-home condition, maybe around 70 Fahrenheit. The compressor is actually located in this outdoor unit here, and the fluid will move from the compressor all the way over to the adjacent chamber, where it's going to enter some duct work that will kind of model what you would see in your house. And as the air will pass over the evaporator coils with that fluid in there, the cooler air will now be dispersed throughout the chamber. And that's sort of an example of how we use both chambers together. And again, the chambers provide very tight temperature and humidity control, so we could specify that to whatever climate condition we are looking for. And that sort of summarizes what we do in terms of testing in the environmental chambers.
Hey, I think it's as good a time as any to take a little detour from our product development journey and talk a little bit about the manufacturing of our refrigerants. We have a lot of dedicated and really expert engineers that design and build and operate our manufacturing assets. For instance, we recently broke ground on the world's largest HFO facility located in Corpus Christi, Texas, where we make the building block, the foundation of all of our Opteon product line. And these are just as important. So as our team is working to understand all the science and engineering and data to develop the best refrigerant products and to find those, we also need to invest in state-of-the-art manufacturing facilities so we can make the appropriate quantities and the best quality, and then move it into packaging and then distribution, so that when we identify a great refrigerant product, that it's available on the shelf in a location near you, so you can use it to delight your customers as well. So always want to give a nod out to that. They don't typically show up in the spotlight too often, especially in the industry things, but rest assured they're behind the scenes making us all successful in our jobs and delighting our customers with great refrigerants. So we're in the engineering lab here with two of our refrigerant engineers, Dave and Andrew. So welcome, guys. Why don't you take a second, introduce yourself, and tell us what you do and the kind of work you're doing here in the developing of new refrigerants.
Hi, my name is Andrew Pansula. I'm a technical service engineer with the Chemours company. I've been with the company now for 7 years. Our group is pretty much at the end of the line, where we are working with end users and OEMs to best optimize their systems for new refrigerants. And there's a lot of work that goes into that. Primarily creating any kind of technical literature that you may need, whether it be PT charts, pressure enthalpy diagrams, retrofit guidelines, really any kind of property that you would need on a refrigerant, our engineering group helps create. We also work in the field to help end users with retrofits. So let's say you had a question on how a valve is going to operate with a new refrigerant, or how's the capacity going to change moving from one refrigerant to another in my existing compressor. We help answer all those questions.
Hi, my name is Dave Snyder. I'm a mechanical engineer with Chemours Refrigerants Tech Service Group. I work between research and development, sales and marketing to support our products, both developmental refrigerants and new, for customers such as equipment manufacturers, design firms, refrigerant technicians, as well as single end users to position our products for your needs. I work in the field doing retrofits anywhere from air conditioning systems all the way up to industrial refrigeration, including recent work that I've done at an industrial chemical plant with a flooded chiller. So while we provide a lot of technical assistance through the phone and email, a lot of the information you need can be found directly online at opteon.com, but feel free to reach out to us directly.
Thanks, guys.
Hello everyone, my name is Jamey Hill. For the past 40 plus years, I've worked in the HVACR industry. In the first 30 years of my career, I was a field technician working on equipment ranging from small reach-ins to large industrial flood systems. Currently, I oversee Chemours training, the Tech-to-Tech phone line, and the Tech-to-Tech email service for our Opteon and Freon refrigerants after they've been commercialized and in the field. The types of training we provide are R22 air conditioning retrofits to MO99 or new 22B, supermarket refrigeration from R22, R44A, R507A to Opteon XP40, refrigerant number 449A. Industrial cold storage retrofits also using Opteon XP40. And a new but very important topic, ASHRAE safety classification A2L, lower and sometimes referred to as a mildly flammable refrigerant. In a typical year, we would train thousands, ranging from first year tech school students to an HVACR engineer. Wholesale branches, conferences, trade schools, and industry associations like RSES, ACA, PHCC, and ASHRAE, we have carried out over the years many face-to-face trainings, and yes, we will be doing that type of training again soon. Webinars or recorded training is available online. Please call the Tech-to-Tech phone number at 866-433-8324 or email us at techtotech@chemours.com. For the past 80 plus years, Chemours has been the leader in refrigerant technology. We are always here to support you and your customers and stand behind our products, answering your questions. Again, thanks for the support and be safe.
Well, that's about all we have time for today. So I hope this information was helpful. If there's anything you want to hear more about or any of our experts you want to talk to, please reach out to us here at Chemours. I hope this gave you some insight, and the next time you grab a jug of Freon or Opteon, you'll know you're getting a little more than just the refrigerant in the jug, but you're getting a little bit of that science, engineering, expertise, experience, and know-how we've developed over the last 100 years. Be safe and have a great day.